Okay, good morning. I would recommend you that you start working on these problems of Demoir's formula. The problems are actually simple. Then I will try to find some hard problems that we can enjoy together, okay? But I would recommend you start working on these problems because if you don't really understand these problems, some of them are good actually, I will discuss about them. But some of them are very simple, I would say. I think pick one section from each exercise just to refresh your memory. And meanwhile, I will try to see what can I find, and then we go through it. Yeah. So pick some of the problems. If you really know what is going on, just immediately jump to a higher level problems. Okay. Okay. If you don't mind, let us go and try to see how Indians do mathematics. Yes, I really love them. The questions are extremely hard. Okay, so we can have some challenge. But of course, these are multiple choice questions. They don't have more than 1 minute or so to answer these questions. But forget about the timing. You want to actually solve them, okay? So one question that I see is interesting, and I would say that's, by the way, at the level, even though it's from an Indian book, but you can understand it quite easily, okay? So the solution, so let me write it for you. So the solution of the equation absolute value of z. Of course, I am working in complex numbers, so whenever I write z, I mean a complex number. Absolute value of z minus z equals to 1 plus 2i. The solution of this equation so let me write what is the solution, because if I give you the choices, you might find a way to find the solution. But solve the equation. Yes. Let me write solve the equation. And I want to wait for you. They get 2 or 3 minutes. I give you 4 minutes. Okay, just do it. I don't know. Even they might get 90 seconds. I don't know. But this is exactly at the right level, I would say. For example, we can consider it A-level questions for our course. You didn't get it? Yes?
3 over 2 minus 2.
I think it's correct. I see it in the options, but I don't know if it's the correct answer. But if you got this, probably, high probably, it's correct. Thank you. So how did you do that?
I started replacing z by x plus y.
Okay, let me ask you one question, if you don't mind, share it with me. How did you understand that you have to do this?
Well, I did some questions in the book and they did use this method.
And if you remember, I told you some equations like this when I was teaching. If there is only z involved, of course you can simply find z. But sometimes in my questions I didn't give you absolute value. I gave you z, an imaginary part of something with z. And I told you that whenever this happens, you need to immediately understand that you have to do this. Work on your memories, okay? So this I would say let z be equals to x plus iy. Then everyone knows what, hopefully everyone knows, what is absolute value of z? The square root of x squared plus y squared, and then minus z, yes? Which is x plus iy. And then is equal to 1 plus 2i. Okay, how did you continue?
Then I first opened the bracket x plus y.
Yes,
I1.
yes.
Um,
So if you don't mind, let me write it immediately. So you open the bracket, it becomes negative x negative iy. But you know, it is a little bit complicated than usual, but not that complicated. Because what type of number you see is a real number. And then what type of number x is real number. So it means that it is natural to collect them together. And then you have minus iy again is equal to 1 plus 2i. So what I ask you, what do you see now? You see a little bit complicated complex number on the left, another complex number on the right. They are supposed to be equal. There's one way to do it. The real parts should match, the imaginary parts should match. Yes? So this means that square root of x squared plus y squared minus x is 1, minus y is 2. But it means y is negative. So at least y is minus 2. I need to find x. But even though this might be a non-standard equation, but it is not hard because you know y. So you put y there, so it becomes square root of x squared plus 4 minus x is equal to 1. Then it becomes a Math 2C problem. It's a root equation. And you know in principle, you should know in principle how to do it fast. So is there any point to raise it to power 2 right now? No, because I have 2 times the first one times the second one. I will not get rid of a square root. So what I will do, I move this to the other side. Yes? And then square it. When I square it, I will get as x squared plus 4. On the right hand side, it becomes x squared plus 2x plus 1. X squareds are gone, so x becomes 3 over 2. Yes, but you have to be careful that because you are solving root equations, there is one of the options here, none of these. Okay, so you have to be careful because might be, I don't know, this is a false root. If you have experience in solving root equations, you know that might be you get a false root. So you have to convince yourself this is not a false root. But is it? If I put it here, so this becomes 9 over 4 plus 4 square root minus 3 over 2. I need to ask myself, is this the right answer? But calculating is not hard. Because 4 times 4 is 16 plus 9, 25. Square root of 25 is 5. Square root of 4 is 2 minus 3 over 2 becomes 2 over 2 and it's 1. So that's not a false root. Okay? So this means that the answer that you provided is completely correct. So z is 3 over 2 minus 2i. Thank you very much. So I don't know. So I would consider it a level problem in our course. Yes? Do you want another challenge or not? Let us do it. Okay, so if z minus 1 over z plus 1, of course, again, I don't repeat, z is a complex number. If z minus 1 over z plus 1 is pure imaginary, complex number, determine let me see, determine the absolute value of z. Pure imaginary, do you remember what's the meaning of pure imaginary? It means that you have a complex number whose real part is 0. That is the meaning of pure imaginary. Okay, I want to wait for you. Answers? Not yet. I will wait. Don't give up. Okay, do you have any idea where to start from? Yes? By the way, I want you to share the ideas with me, and I try to follow your ideas. Most of the time, you will not be able to solve the problems. This is, I'm repeating it 100 times, yes? And that's the important part of mathematics. We cannot solve the problems without trial and error. I have seen this attitude from students that if you follow one strategy and it doesn't work, you give up and wait for the solution. But that's not the right attitude, yes? So you have to change your perspective. I just want to share, you please share your ideas with me. How do you think about the problem? Yes?
I do as before. I replace z with x plus yi, but now I subtract 1 and I get a new complex number. So
Yeah.
I get a new real part and the same imaginary part. And then I use the division formula.
So my question is that how many of you tried this method? So she said, I did the same. She said that she replaced z with this, because z is a complex number. And then what happens, some little algebra happens, and then I get two numbers divided, two complex numbers divided. Isn't it natural then to use the division formula or whatever? Yes? Okay. How many of you tried this method? So it didn't work? Okay, so I don't know how many of you are thinking about the problems. That is a better question. And I want to see what fraction of you were thinking in that way. I would call it a good way. It's a natural way to do. Yes? It's really natural to do it in that way. Unless it doesn't work, or you are more smart or more experienced, you find a nicer way. The solution that Indian did it is different, but I would say that this will work. It doesn't mean that we have to go their own way. Yes, and then I will try to find a better way than Indians. Probably we can find something else, okay? So what we can do here, let us follow this. And then this needs you have enough skill in algebra. Otherwise, because it becomes a little bit complicated, you might get lost. Okay, so you would say that, okay, z is a complex number, so this is something like that. I put it there, it becomes, and let's do some of this in our head. So this minus 1 will affect the real part, yes? And then z plus 1 will affect this one. Right or not? Okay. But then if you need immediately to realize that I am dividing two complex numbers. By the way, all of these are at the level that we have. So from information point of view, we have everything, but you have to practice more. So I have dividing two complex numbers. There is one rule for dividing. What was that? Yeah, you have to multiply by the conjugate. So what you write, so you write x minus 1, let me write it quickly, and x plus 1. And then you multiply by the conjugate. Conjugate means x plus 1 minus iy, x plus 1 minus iy. I agree that the algebra becomes complicated, but it is doable. Yes? First of all, the denominator, what happens for the denominator? It's a conjugate rule. It becomes the first one squared minus the second one squared. But the second one squared is iy squared, which is minus y squared. So this becomes positive y squared. Yes? And then let us do something in our head. This one will be multiplied here, and here, this one and that one. Okay? But this you can do. This multiplied by that, remember, what is the answer? It's a conjugate rule again. It becomes x squared minus 1. Yes? There is another, of course, in principle I should multiply this. This is the term for this one. But I know that this one multiplied by the last one will also give me a real number. Yes? So iy times minus iy. What is the answer? Iy times minus iy. What's the answer? So why don't you answer? What is the answer?
Y squared.
Y squared, because I times minus I becomes minus I squared. I squared is negative 1, so it becomes 1. Y times y is y squared. Yes? Okay? And then this one multiplied by that one gives me an I, and this one multiplied by that one gives me an I. So then I will start with the positive one, because I'm an optimistic person usually. And then I multiply this one by that one, yes? So you see, the algebra was probably very complicated in your head, but it's not that complicated. If you want to write every detail, yes, it becomes complicated. But then, so everyone agrees with me. So I always double check because I do something in my head. So I will multiply this in my head again, y times x plus 1. I have a factor of I factor, that's correct. And then I have this one multiplied by that one, that's okay. Am I right or not? Okay. So now, what can I do? I can, if you want, I can simplify it a little bit more. This expression divided by that expression. This is my real part. The imaginary part is this part. So if you want, I can multiply yx minus yx cancel, y plus y to y. Yes? This is my real part, this is my imaginary. So what is the conclusion now, by the way? You see the problem is extremely simple, and you just use the national. So can you finalize the problem? Go back again, read it and finalize it. Yes?
Shouldn't the first one be equal to 0?
Okay. Yes? Because this is telling you that it's pure imaginary. So it means that this complex number, which is this one, should be pure imaginary. It becomes pure imaginary if the real part is 0. Yes? So the real part becomes 0, means that x squared plus y squared minus 1 divided by x plus y plus to the power 2y squared is 0. But the fraction is 0 if and only if what happens? The numerator is 0. So x squared plus y squared should be 1. But isn't it famous when you come to a complex number? So it is absolute value squared. So this is absolute value z squared, yes? Is equal to 1. But what is wanted? Absolute value of z. So we are done. So absolute value of z is 1. It cannot be negative 1, yes? That was one way, and I would say that this is a very good experience. You need to learn. If the algebra becomes so complicated, I will not continue it when I am solving a hard problem. I will reconsider, might be the designer of the question have thought something else. But if it is not that complicated, I can just do it, and that is completely, if that is 500 points, you get 500 points there. Yes? Yes or no? But let me also introduce you the Endian solution. Okay? The person who actually solved the problem when I see it is this. So this is unusual way of thinking, but if you practice more, then you will enjoy these kinds of things as well. The person who has solved the problem is saying that, okay, you are telling me that this is a pure imaginary number. Instead of starting from this one, I would say that, okay, z minus 1 over z plus 1 is a complex number. But you are telling me that's a pure imaginary number, so it means that this is I times a number alpha. Yes? This is the way that they have done it. And then what they do, they find z. This is a strange logic, because then this is the natural logic we have to do. But if you have more experience, might be you can find these kinds of shortcuts. They are better solutions. So when you say this is an imaginary number, do you understand that is correct? I don't know, if you ask me what alpha is, I don't know. But I know that this number, whatever it is I alpha, what of course alpha is real. Yes? And then I will try to find z. These skills at this level you should have. Finding z shouldn't be a problem for you at all. Yeah, so how can I find z? 2 seconds, 1, 2. The method. Okay, 5 seconds. 1, 2, 3, 4, 5. Okay, let me ask you a question. In Math 2C, how can I find x? 1, 2, 3, 4, 5. Tell me something. So why? Okay, so you multiply, yes? Why don't you do this here? This is the problem of students. They know how to solve it. They don't recognize that's the same problem. This is a really big problem of the students doing mathematics. I am completely sure that you can answer this one, but do you see that this is the same problem, isn't it? And the only thing is that instead of 5, you have I alpha. So the strategy shouldn't change. These are the things I want you to learn. So, okay, I multiply. So I multiply z minus 1 is equal to z times I alpha, so don't worry, I alpha z, and then this one times that one is I alpha. I am looking for z. So I bring z to the left, and I move 1 to the right. But what, where is z? Okay. And then I factor z out. What is z? Z 1 minus I alpha, and it's 1 plus I alpha. I am looking for z. Agree? Yes? Okay, now the absolute value of z is 1. Can you see why? So this is a nicer solution, isn't it? It's shorter. Why absolute value of z is 1? I'm waiting for you. Yes?
Because it's a pure imaginary number.
No, it's not a pure imaginary number. Be careful. The fraction was pure imaginary. Actually, this is no longer a pure imaginary number. So I'm claiming that it should not be hard. Of course, it might be a little bit hard. It's a little bit technical. So why the absolute value of z? The reason is that the absolute value of z is the absolute value of this guy. By the way, don't think that I will not give you sort of questions like this in the exam. Because if I ask you find the absolute value of this, it should be extremely simple for you. How can you find the absolute value of a complex number? If you don't know, let us start teaching complex number all over again. So how should I find the absolute value of a complex number? Yes?
You take the square root
Of
a and b.
A and b. But a and b are not clear, so I have to write it in the standard form and then read a and b. So this is doable, not hard, but better than that, much better than that. If you respect the formulas, I told you the absolute value of a fraction, if you go back in my teaching, I had them. It becomes absolute value of the numerator divided by the absolute value of the denominator. Yes or no? Okay, but now can I calculate the absolute value? As Kevin mentioned, it is 1 squared, which is 1 plus alpha squared. And what is this one? It's square root of 1 squared plus minus alpha squared, which becomes again alpha squared, but this is 1. Yes? Okay, let us try to find another way to solve the same problem. So I think this is a smarter way, yes? The algebra is not that heavy, especially if you can recognize this immediately. You don't need to even do this calculation. Okay, can you tell me how can you interpret a pure imaginary number in a different way? By bringing the notion of the conjugate in. If you have a pure imaginary number, and if you take its conjugate, how this new number is related to the old one, how the conjugate of a pure imaginary number is related to the number itself. Do you remember what was the conjugate? Yes? So if I have z equals to a plus bi, then z bar is defined to be b minus I bi. But now my question is that if my starting number is a pure imaginary number, what happens if I conjugate it? Yes?
The imaginary part, the sign changes.
The sign changes. So that's good. So this means that a number is pure imaginary if z bar is equal to minus z. Yes? Is that right or not? Yes or no? Okay. So now we are talking about this number. They are telling that this number is pure imaginary. So what does it mean? It means that if you take the conjugate of this number, it becomes what? It becomes negative of the number. Everyone understands that? So they are telling you that the whole number is pure imaginary. According to what I told you, it means that if you take the conjugate of that pure imaginary number, it becomes negative itself. But do you remember what can I do with a bar on a fraction? It becomes bar of the numerator, bar of the denominator, and then bar of the numerator means bar of this one minus bar of that one. But what is one bar? 1 itself. The bar of 1, because 1 is 1 plus 0i. If you change 0 to minus 0, it doesn't change. So this means that I can immediately write z bar minus 1, z bar plus 1. Because it becomes the bar of the numerator, and then I break the bar, z bar minus 1 bar, but 1 bar is 1. And the same thing here. Yes? And if you don't mind, let me multiply this minus sign in. This becomes. Yes or no? So this is understandable. And then what I do, I just multiply these two, because if this is equal to that one, this multiplied by that, it should be equal to this multiplied by that. Yes? So let us see what happens. Z bar times z plus z bar. Yes? And then I go here. Z bar minus z. Did I do it correctly or not? Z bar. Oh, so I have to do 4. Sorry. Z bar times z. Z bar times 1 minus 1 times z minus 1 times 1. On the right hand side, 1 times z bar, 1 times 1, and then minus z bar, and then minus z. Understandable? Okay, let us see. But can you tell me what this guy is? Absolute value squared. So this is absolute value squared. By the way, what I'm getting rid of, so z bar and z bar are gone. Minus z and minus z are gone. This is also absolute value of z squared. I move it to the other side, it becomes 2. Yes? And then I move minus 1 to the other side, that also becomes 2. So then absolute value of z is how much? Yes? So this is now my version of solution. So I will prefer this one. The reason is that I work in the complex number itself. I didn't go to real numbers and come back. So I did all my calculations with complex numbers. So that's also the third solution. But what I'm trying to say is that I would say that most of you, if you are interested in mathematics, you should be able to solve this problem. Okay, are you ready for another challenge or not? So I really enjoy this problem now. And by the way, so when I see nice problem, I cannot resist, you know. And then according to Jordan Peterson, the highest, the most severe addiction is math addiction. I didn't know about that. So might be that's right. Okay. But I didn't exactly listen to that talk because that was one part from the talk. But that's a nice addiction if it is addiction. Okay, so let me ask you this problem. I want to simplify this problem because I think that would be too hard. I want to ask you one question. I give you a complex number z whose absolute value is equal to the absolute value of z minus 1. Okay? And then I am asking you, can you calculate z plus z bar? That's the question. These questions are a little bit harder because might be there is no natural way to think about it. So it was natural here, but of course that's also probably natural. I want to wait for you, okay? I want to see how do you think about this problem. I give you a complex number that satisfies this equation, and I am asking what is z plus z bar? Yes? Okay, what happened? Yes?
Is the answer 1?
1. Thank you very much. Thank you. So, let us solve it in 3 methods again. So what is the natural way? I don't know why still you don't like natural ways to do. Yes? So you should do it in a natural way. I don't know why. So this is, you cannot say that I don't have any experience now. You have it on the board for the second time. This is the third time, yes? So I would say that let z be equals to x plus y. By the way, I would consider it A-level problem. A-level, probably C-level problem in our lesson. So let this. Then what should I do? Absolute value of z is what? Is x squared plus y squared square root. But what is z minus 1? Z minus 1, because 1 is the real part, will affect this part. It becomes x minus 1 plus iy, isn't it? And now if I ask you what is absolute value of z minus 1, you can answer it immediately. And now what I am telling you is that these two numbers are equal. So this is, I want you to understand from your perspective. How many of you did this? So why didn't you get the answer? Okay, so let us continue. See what's the problem. So this means this number is equal to that number. I want to fix it if somehow you have some weakness in your algebra. So can you tell me what is the natural step after that? Because this is a natural, I am equating them. What's the next step? Square it, so I just get rid of the square root signs. So far so good. But then, let me just do it step by step, which I don't like that much, but anyway. So then what should I do? What's the natural step to do? Everyone, just say it. Y squared is cancelled, yes? And then I have x squared is equal to, I raise it to power 2. And then what is cancelled now? And then I bring it to the other side. X is 1/2. Okay? So if there are 3 points up to here, you have already got 2 points. Okay, so what is the last part? I don't know how many of you could get this correctly. X is equal to, so okay. Okay, so that was so that's very good. So you got 2 points so far. But how did you solve it then?
Since x is the real number of the complex formula and c times c bar.
Yeah, the question is find z. Exactly, z is this one again plus z bar. So you might still think about how can I find y, but y is irrelevant because this is cancelled, yes? And then you get 2x. This is the only thing that you need. So 2x is 1. That's the answer. Was it hard? No. Yeah. So and then, to be honest, it takes under 5 minutes. This time I will not give you long time. So 90 minutes fixed. You have to do it. Yeah, because I don't know. This is not really taking so much time. If you really take it, it's under 5 minutes. And 8 questions, 15 minutes. Yes? And then other questions, 15 minutes probably 45 minutes. No 90 minutes. But if I give you 3 hours, I know that you will sit. Yeah, I don't know what you are doing there. Okay. Okay, now let me solve this problem another perspective. I want to tell me, how can I solve this problem geometrically? I want to see how many of you remember what I said. Geometrically, it means that I go to complex plane. By the way, this is not the method provided by Indians, so this is one solution. It will provide another method, they did it, and I will give you another method by geometric perspective. So if you can solve this problem using geometrical ideas in the complex plane, it means that you have a very good grasp on complex numbers. So how can I interpret this equation geometrically? So geometrically, it means that you imagine that you have a coordinate, you have a plane of complex numbers, real and imaginary. This we had it in our lesson, and it is in the book. It's not hard. Where is z? Can you tell me where z is? What is the interpretation, geometrical interpretation of absolute value of z? Yes?
It's the distance
To the
from the origin to z.
This is the distance from the origin to z. But what is the interpretation of this? We discussed about quite a lot about this. You remember I told you what is the interpretation of this. And I also told you what is the interpretation of that. So what is the interpretation of absolute value of z minus 1? And I remember you learned very good at the spot. The problem is that you forget. So what is the geometrical meaning of absolute value of z minus 1?
The distance from zero
To 1. Where is 1? 1 is here.
Oh.
Yes? I am interested in a point, or not in a point, in all points whose distance to the origin, which is here, is equal to its distance to 1. So what are those points? One of them is clear, is the midpoint. Yes? But is this the only one? No, there are infinitely many. What is that? That is, do you remember? Perpendicular bisector. What is this number? This number is 1/2 because that's the midpoint. But I hope that you agree, every point that I choose here, its distance from the origin and its distance from here are the same. So that is the possible points. Now, what is z plus z bar? Z is somewhere on this line. Wherever it is, I don't care. This is z. But tell me, where is z bar? Exactly below. Yes? And then z plus z bar, we had a formula. It is 2 real part of z. Yes? So what is the real part of z? What is the real part of z? Is 1/2. Yes? And you multiply it by 2. Becomes 1. So this is just based on geometry, no calculations at all. Yes? Another one that they have done it, that I want you to learn, whenever you want to talk about absolute values, usually in complex number, it is better to talk about absolute value squared. Why is that? Because absolute value squared has a nice formula, and that is z bar. Yes? So remember, this is a trick you need to learn. Sometimes, if you have something about absolute values, it is better to answer it. It's better to answer it in the form of z bar. So I square it. Okay, and then tell me what can I. This is clear, so I will write it myself. But what can I write for this one? Can you help me? This is z minus 1 squared. What can I write for that? According to that formula? Yes, what is the answer? What is the interpretation of this? This tells you that if you have a complex number, any complex number, and you want to take absolute value squared, there is a rule for that. Just multiply that number by its conjugate. Yes?
So you write the conjugate.
Yeah, exactly. You write this and multiply it by its conjugate. So the conjugate is this one. But you learned that the conjugate can be broken down into pieces when it comes to this sign. So what happens? So if you don't mind, let me write it here. Z bar is equal to z minus 1 multiplied by z bar minus 1 bar. But 1 bar is what? Yes? And then what you do, you multiply z bar, z minus that one. This is minus z bar, and that's positive 1. That's a very, very nice solution, because whatever this is gone. And then you move these two to the other side. It becomes z plus z bar is 1. And that's exactly what you want. Yes? So you see, again, 3 different ways. More or less, this is natural, very natural. You don't need to be creative at all to do this. So you have to be creative a little bit here, but not that much if you respect what I told you. Whenever absolute value of a complex number comes in, remember this formula. So this is the way in the back of my head. When I see the absolute value of complex numbers, I probably pay attention to that formula at some point. But I would say this is a very nicer way. You don't even need to calculate anything. So this was the natural way, this is the Indian way, and that's my way, okay? So you can keep me points, okay? Yes?
So you can view z minus 1 as a complex number even if it's not written in the standard form.
Yeah, exactly.
Okay.
Yes, because you're working, because the complex number is the most complete set of numbers. So whatever arithmetic operation you do there, it remains there. So if I ask you where is 1, 1 by the way is the natural number.
Yeah.
It's a natural number, but it's also a rational number, it's also an integer, it's also a real number, and it's also a complex number. So you don't worry, that's a good point about working with complex numbers. Whatever you do, it's still there. Yes? Okay. Okay, so let me write something here which is a little bit actually related to the Demoir's formula, okay? So, let me write this for you here. So, first of all, I want you to see, do you have it in your memory or not? What is the Demoir's formula? So the Demoir's formula, if you remember, is this. If you have this very particular combination of a complex number, so that the real part is cosine of an angle and its imaginary part is the sine of that angle, and if you want to raise it to a power of an integer, any integer, what is the rule? Instead of multiplying it n times, if you do it at the end, everything will be simplified and you see that the answer becomes cosine n theta plus I sine n theta. Okay? By the way, before passing, I just want to tell you that how complex number can help you to find trigonometric formulas. For example, if I ask you to write this to power 2, this expression can be calculated in two different ways. One, using the Demoir's formula, which gives you what? Cosine 2 theta plus I sine 2 theta, yes? And another one is the usual way. Raise this one to power 2. 2 times the first one times the second one. And the second one to power 2. But the second one to power 2 becomes minus sine squared, yes? If I combine them, I can write the real parts into one formula, into one pair of brackets, and then I can write this. Yes? And now see, very, very interesting thing happens, yes? Because I have this complex number equals to this complex number. This can happen only the real part is equal to that and the imaginary part is equal to that. You got the formula for the double angle in a matter of seconds. So sine 2 theta is 2 sine theta cosine theta, and cosine 2 theta is cosine squared theta 1. If you go back to my lectures, when I was doing it in the normal way, we had to do a lot of geometry. Because if you go back, I had to solve the problem with the cosine rule. So be just careful. If I want to do it, I have to prove the cosine rule. For the cosine rule, I have to use 2 or 3 Pythagoras theorem to get the cosine rule. And using the cosine rule, I find the addition formula for cosine. No, subtraction formula for cosine. And then from there, I find the subtraction and addition formula for sine and cosine, everything, and then combine them to get these two. So if you really want to calculate, but this is a matter of seconds, and it's very, so you see that complex numbers, even the idea was very strange to imagine a number whose squared is -1 exists, gives rise to very, very simple calculations, even in the realm of real numbers that we are doing. So you see that's a proof of the double angle formula using complex number. It's just 2 lines. It's actually very simple. But now I just write an equation for you. You can think about it yourself. We will not have time to solve it. So this is the Demoir formula. Now I am telling you that if z is equal to cosine theta plus I sine theta, it's very simple, by the way, and n is an integer, prove that z to the power of n plus 1 over z to the power of n is 2 cosine n theta. Okay. So now you can practice on this in your Easter time. So you don't need to be worried of what we can do being far away from mathematics, yes? Whenever you are getting bored, you can send me an email. I can send you a set of problems, so don't worry. Okay, happy Easter. Thank you very much.